Well, hi, good morning. Thanks for joining me in my shop. I'm going to be trying to finish off the component side of this radio. I think that all that amounts to is just changing this last big capacitor out of there. Look at this thing. This is a 0.1. Here's its replacement. A little smaller, eh? That gives you some idea of the vintage of this. Some idea anyway. Rest of the previously replaced capacitors look great. And there remains in this radio quite a few of these black ones here. I've got a couple of those I removed, and we're going to test them. We'll see how they come out. So first, I'm gonna just replace the white one with this, and then we'll be testing capacitors. So I'm about to solder this, and I'm using this little soldering iron here to do it, as opposed to the big one I used to use. And if you've been watching me use this one for quite a while now, and it has an improper tip on it. It has a wedge tip. Not improper, just not the best. I have new tips waiting, and I'm waiting for a tip thermometer to come so I can put the proper tip in and then set the temperature up properly. When I realized I've got this viewer here, maybe I can view the temperature of the tip with this. Let's see. It's a question of how high it'll go. Well, I think you can only set the top number here so high. I think it was a lot higher than that. Let's see. Wow. I don't even need to set this number. Let's find out how high you can set it though. 250. 300. 300. That's the top. That's the top of the scale. Doesn't mean that's the top of what this meter can read. Okay, I'll put the tip in front of it here. I'll try and get the... well, it's telling me the high temperature right now, 230. If you can see, can you see what it's doing? It's hard. You can see the white plus. There's a red plus right in the hot spot there. You just can't see it on camera. The hot spot's the tip. That's interesting. And it's telling me it's, well, I just went to sleep. Let me get it going again. This soldering iron has a shake feature in it as soon as you shake it. So there you can see the temperature now. 215. It says, whoa, wait a minute, this is way off, way off. Make sure this is going. So my machine said, the machine itself says 356, and this guy is saying, oh, it's C. It's all C. Maybe that's why I'm having such a hard time with this soldering iron. It's actually not that hot. So I've never calibrated this one. So I'm getting 220 C. Is that enough to melt solder? 220? I don't know. Okay, just a little bit of experience there, and I'll put this away and think about what I was doing there. It'd be interesting when I get a real tip thermometer here. We should be able to compare everything, and then we'll be thoroughly confused as to what is really correct. I think at 200 C, I don't think you can melt solder. I think you have to be a lot higher than that. Okay, here we are. So I think I've changed out all the parts I really intend on changing out. Let us turn our attention now to testing these guys. Let's start with the one I just took out. So this looks great. Looks well sealed on the ends. This is in great looking shape. 600 volt guy. Need some leads here to do this. So many of you have seen me do this. You may have seen me do this before, but if you haven't seen me use this before, capacitor checker here works in two ways. One is it puts a DC voltage on the capacitor and measures the leakage current, and it's very sensitive to a tiny leakage. That's the first test we're going to do, and maybe the only test. The other one is it'll measure the capacitance. Okay. Watch the eye. When I first hit the switch here, the eye will snap closed and then it will drift open. If it opens up like this, then the capacitor has no leak. If the capacitor is leaky, then the eye will not open all the way or may even stay closed. 50 volts, here we go. So it popped right open. 250. So this capacitor tests excellent. Just as it looked, just as I suspected. So we'll measure it now, its capacitance. 0.1. 0.1 is on this scale somewhere. There it is. You see the eye swinging right open. That's another reassurance that the capacitor is good. And can you read that right under the thing here? 0.1. So this is a perfectly fine capacitor I just took out. There was no reason to take it out of there. That certainly reassures me that all the rest I've assessed as being good are almost certainly good, because I think they're better quality than this one. Now I'll start looking at these guys, which I'd be very surprised if these ones test so good. These being original with the radio. So these are from 1940 something, I think. Okay, 50 volts once again. Right open. Now, a capacitor like this pops open. Sometimes I think it's probably not connected inside. Let's go up. We should see some charge time on here. Right open. Right open. Okay, so this is also a 0.1. We should get the response in the same spot. 0.1. So now, can you see that? You can't see it in the camera, but what's happening is the eye is changing ever so slightly. Let me just see if I can get this effect. If you're using this instrument, then you're probably seeing this effect too. Let me see if I can just grab my small camera here and we can take a quick look at that effect, because it happens a lot on this machine. Let's see now. You have to bear with me while I make a few, I'm going to stop the video and make a few camera adjustments and make this work right. Okay, so you can see what I've done. I just stuck my camera right up close to the magic eye there and adjusted the camera to give a nice view of the magic eye. You can see I still have this capacitor connected. I'm still on the capacitor checking side of things. Okay, let's go back over to the voltage side here. Okay, here, let me just go back like this for fun. Now I'm going to switch cameras. Wow, isn't that cool? So I'm going to flip this now to the 50 volt DC test. See the eye open. Lots of funny patterns in there, eh? Isn't that interesting? And now I'm going to hit the switch and test the capacitor. Here we go. So you see it. It did quickly close and pop open again. In fact, it pops open a little wider than otherwise. I'll put this up to 250. There we go. Apply the voltage now. So this is really indicating a highly reliable capacitor at this point. The capacitor will discharge through a short that's set up by the machine, by the way, in case you're thinking, don't switch over there. Okay. I'm going to adjust. Watching with my own eye, something happened right there. And here's what you see on the eye. You just see a little bit of, excuse me, dulling at the overlap at the bottom there, but it never separates out or anything. So now when I see this in a capacitor, it usually indicates, excuse me, it's leaky. Yet this one tested without a leak, and yet it has this effect. And its rate, it's actually above 0.1. This is 0.1 right here. It's a little above 0.1, which you gotta kind of wonder about. Let me just check. I'm just moving the dial everywhere here. So I've seen this effect quite a bit. I always put it down to a leaky capacitor. But so was it worth changing this out? Oh, I'm sure it was. Let's try another one. Similar type of capacitor here. Similarly constructed. Okay, now if you just bear with me, I am going to make a quick change to this camera view here. Just bear with me. I'll do this right on like this, and then we will just click there. 3 more clicks, maybe even just 2 more clicks, maybe only 1 more click will do it. There it is. Okay, so now you can kind of see the whole show happening here. Okay, 50 volts on this capacitor. Again, it's testing marvelously good. 150 volts. So this again is showing no sign of leakage through this capacitor, which again is just hard to believe. And this one, what size is this? I don't know. Well, we'll try to find out. It's got to be smaller than the. We'll probably find it on this scale. Okay, now we're looking for the eye to pop right open. There we are. Now it's right at the end of the scale. It's a little hard to see with the pointers up there, and it's just going right to the end of the scale. So don't trust this machine when it does that. Let's see if we can get one. Here's one that's more upscale. Right here. It's opening right up. So son of a gun, this capacitor appears to be testing good. Let's just see what it's testing at. So we're on the 0.001 scale, so it's testing at 0.003. 003. You know what it says on it? It has the number 3000 on it. That's suspicious, eh? Let's see what this one says. You can only do, okay, so look at that, 3000 picofarads, 0.003. That's 0.003. How much you want to bet this is what this, so okay, here's another, a bad looking capacitor. Turns out to be perfectly good. Okay, this one says 5600. So the last guy who did the capacitors in this radio picked a few to change. This was probably 20 years ago. Picked a few to change and changed them, and left a few in, which I have now changed. Those few I'm now testing turn out to be, well, so far, okay. What did that guy know? Hey man, I don't think this should be affected by. Okay, that's fine. I didn't think this would have any effect on the. When I have this set to leakage test, I didn't think this dial would do anything. What's going on here? It's not behaving consistently at all. There's some noise. It's some like a noise in this control that's doing that, I think. Okay. Back to what we're doing. 50 volts. Does it leak? Another one that's testing perfect. I gotta wonder what's going on with my tester. I gotta dig out a bad capacitor here. Oh my gosh, I put 250 volts tested fine. Okay, and this one said 56. Let's see what happens. 56, so that's 0.005 or something like that. Oh, look at that, opening right up. And that's happening at, make sure I get on the right scale here, 0.5. What scale am I on? No, I'm on a different scale. 0.5, 0.005. As in 0.0056, as in 5600. It's another one testing perfectly good. Okay, so this guy, now I'm thinking, the guy who did this work before, he knew what he was doing better than I do. He knew which capacitors to leave in. Now these ones are notorious. This is a solar, so when I say these ones, this style with this molded plastic two-part case, these can be bad guys. This particular brand maybe not. But some of them are ones that are labeled Hunts, that were made by the Hunts company. Bad, very bad, very bad. Okay, leakage. Again. You gotta start wondering here. I gotta start wondering. I'm gonna put this resistor, and this is a 47K, I think, or 470. It's a big resistor, but it will look like a leaky capacitor. Something wrong here. Something's definitely not working right here. How can those not be connected? Oh, what happened? I moved the camera. I'm discombobulated now. Can't get any leakier than that. I feel like I need to dig up a known bad capacitor now. So, okay, well, let's carry on. Oh yeah, we're going to measure the value of this one. So those quick double checks I just did suggest my instrument's working fine. 0.01. That gets on this scale. So there we are. Now it's opening pretty good. Not all the way though. And that would be again 0.001, 0.005, 0.01. It's about 0.01. It's 0.01 right on it. What have I got left to test? Oh my gosh. I didn't find one bad capacitor. How did the guy know enough to, well, I'm assuming he replaced the bad guys. I suppose I could have looked at which capacitors were changed and studied what it was about them. Perhaps they're all blocking capacitors, perhaps they all have high voltage across them. Not all capacitors have high voltage across them. Maybe. I don't know. Okay, we're ready on this little guy. nothing leaking at all. Now, how big is this one? And it says 120A is what it says on it. 120. 120 picofarads probably. Okay, oh, right here. And where is right here? It's opening right up. So this is the point 4 zeros and a 1, 3 zeros and a 1. So 3 zeros and a 1 and a bit more than a 1. 3 zeros and a bit more than a 1. That would be a little more than 1,000, and this is 1,200. No, a little more than 100, and this is 120 here. One more. This one says 100B on it. I don't know what the B is. 100. So without even doing the high voltage leak test, the eye is partially opened. We go down in size, and there it is. So those two capacitors tested perfectly fine. These two got replaced because I was getting desperate and I was searching for my own mistake, making more and more mistakes, really. Multiple mistakes multiply. I guess that's the lesson there. And is that it? That's all. The rest are resistors. I'm not concerned about testing. Nope. Oh, one more capacitor in here. Let this be a bad one. 0.05. Feels plenty bad. Please be bad. So did I waste my time and my client's money changing these capacitors out? I don't think so, really. The only way to know for sure is to do something like this anyway. And I've pulled out lots of capacitors that look exactly like that and test like a wet sponge. Please be a wet sponge. 250. Wet sponge. And what did I see on this for size? This is the tone one. Now this is the tone one that we had bad tone control. I changed it. We got good tone control now. 0.05. I think it's a 0.05. I think. Okay, now we gotta watch very closely at what's happening to this eye. See the dip right in here? I think, you know, if the capacitor were perfectly good, it would open at this point, not do that. And that happens to be at, well, it's close to 0.1. So 0.05, 0.1. Is that right? Yeah. So again, it's reading high, and I don't think capacitors increase in capacitance. In reality, they go the other way. So I think my machine is thrown off by a leaky capacitor that for some reason, all these capacitors are testing perfect on my tester. It really does raise a little bit of doubt. I gotta dig out a bad capacitor. The garbage day went by, so they are all gone. I'll keep my eyes peeled for a known bad capacitor and check it. I'm looking around right now. No, can't find one. What? Son of a gun, eh? Okay, so that's the capacitor checking done there. What should we do next on the radio? Okay, gotta think of what's coming next. Okay, so I was just working on the video, thinking about the tests I did on capacitors, and how come they all passed the leakage test, but some of them showed signs of leakage when I attempted to measure their capacitance. And it dawned on me, oh my gosh, I probably have this control set wrong. And when I checked it, sure enough, it was set like this. For electrolytic capacitors, this is a mistake I make with this machine regularly. So we're just going to retest the last capacitor. You see it sitting here? I'm just going to retest it on leakage, and you know what we're going to find? We're going to find that it leaks. So on 50 volts, what do you do? There, it's shot. Okay, so I'm pretty sure if we quickly grab, hey, let's grab that big white one now. Now I'm curious again. Grab the big white one. Okay, the one I'm talking about is this big white one here. This one may test good. It may test good. 25 volts. Okay, so you can see it. That's right, 150. Well, still holding in. 250. Yeah, so this guy's still testing good. Now think about it. This is a replacement that somebody put in part way along. Okay, and it's not nearly as old as the originals. Here, let me click the right thing here. So we'll test this guy here. Sealed tight. Wax molded paper capacitor. That's what it's called. Wax molded paper capacitor. How do you do? 50 volts. 150 volts. 250. Doing fine. Okay, now I'm going to grab one of these older guys again. This is a different older one. Here, have a look. One of those guys which left me scratching my head how it could look so bad, be so old, and test so good. I should have been suspicious right away. It's probably something I'm doing wrong. That's probably what it is. Here we go. 50 volts. Oh, he looks good. 150. Well, a variation between capacitors here. Okay, I just got to be a lot more careful with that instrument. I need a little checklist or something like that. Make sure I have it set up right before I do it. So, okay, I think the story is the second test where I attempted to measure the capacitance, and the measurement showed that hazy response or weak response. That's indicative of a leaky capacitor too. So I think we can deem most of these old guys leaky. Oh, wait a minute. Let's try one more. I've got those mica or ceramic capacitors. Stuck one in there right now. Let's just take a look and see what happens here. 50 volts. Beautiful. Let's give it 350 volts. No problem at all. So I think that's also reassuring that those black style capacitors do have a long life. And I mean, nothing's 100% of course, but well, I think it might be a good time to turn my attention to the speaker here. And what I've realized almost right away is this isn't as difficult as I thought. I pictured myself trying to put this speaker into the cabinet, but really I just have to attach it to the speaker baffle board here successfully. So I can just work at it on my bench. Now my theory here, let's see if I get this correct. So this is the way the board goes, like this. Yeah, lots of clearance in here. So my thinking is pretty simple here. If I have the speaker at a inconsequential angle, which would be flat like this or completely turned upside down, the cone is going to center itself. Let me say that again. The cone is going to center itself. Whereas if I'm trying to install this way, I'm trying to get it in and installed, almost certainly the cone will sink and be off center. This feels pretty well held. Now there's a spider back here, and I don't mean a real spider. There's a component of the speaker here that holds the cone centered. And it looks like probably this cone has been held centered by this the whole time. So it could be these outer edges are really not as critical. Getting them positioned. They will find they're in their natural position right now. If I were to lock this down, probably the speaker's okay. I see that the center cover here looks like it's been lifted. Looks like somebody's lifted it. Okay, so now the thing about this is we don't want any dirt of any sort getting past this guy here. Yeah, see, he's come loose. So that'll have to be when you work on a speaker, you can really hear what you're doing. It sounds like I'm viciously tearing at this. So that's pretty well attached otherwise. I'll just put a little bit of glue back in here and close it up. Now how can we know if it's got dirt in it? Wow, I did a 1929 speaker there a couple of radios ago. It had so much dirt where the voice coil slides up and down inside the magnet. The dirt was jamming the coil. There's chunks of paint. It was chunks of paint. So I'll try flexing the cone up and down and just listen and feel. Feels like the cone is very weak over here. Let's try it here. So what I'm feeling in this is quite interesting. What I'm feeling in this cone is I'm pushing it past, I don't know what to call it, a tension point. If you can imagine this, you see this outer ring, not the outer ring, the second ring here, the larger ring here. And that's what I'm pushing on. And I think as this ring of cardboard goes down and the outside can't go down because it's here, the actual dimension from this inner ring to here, it's a simple idea here. I'm having a hell of a time explaining it actually. The diameter of this part of the speaker is actually larger than the opening it's kind of attached to here. Explain that. Very, very good. Here, watch me do it again and I'll describe what it feels like. Whoomp, 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 whoomp. You have a hard time holding it in the middle. Whoomp. Now most of that sound you're hearing is just the edges flopping around here. I don't feel a slightest sense of any kind of rubbing in the voice coil. So maybe the situation is that this is unimportant. The fact that it's loose out here. The spider's doing all the work of holding this thing perfectly solid. This whumping effect, this is not good, because if you have like maybe some bass and it's going to try to pull the cone this distance, like this, this whumping thing is definitely going to fight the trueness of the sound. I guess that's the best way I can put that. So this all looks pretty easy now. So going back to my earlier idea, I threw out yesterday and I'm still happy with it, mostly because I don't have any other solution in hand, and that's to fill the gap here with this as a gasket. And I can go around a number of times, and build this up a little bit, which might be a good idea too. Go around and around and around. I have to decide whether I want to try to stick this on the speaker and then put the speaker on the board. Stick it on the board. Oops. Whack my microphone there. Lower the board on it. Have the board on the bench. Lower the speaker onto it. Which is just my preferred way. I think this is really a better thing to do here. Have it like this. A little bit of dust or something in there. Dirt. Have it like this. Boom. Oh, don't boom it so much, Jim, because shameful. This part of the speaker rides above here, so when I put it on the bench, it's actually jamming the cone up. Now, what about? I just kind of got the idea that there might be something underneath here. Some kind of dirt or something underneath that might cause a problem. Once you put this together, like once I have this together, I don't really want to take it apart. So here I can see when I push here, this part comes up. So it's rocking on a fulcrum in here. And what is that fulcrum? I don't know. Nothing I can do anything about. It doesn't feel like there's any real debris in there. So next stage is going to be to strengthen up these defects here a little bit. Is that a hole right through it? Yep. And then up here. Yeah, I can see the light through it. It's another little weak spot here, 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 and here. So basically it's producing these, I guess we can call these lateral small tears in the area of the cone that's doing the hardest flexing work. Where here it's held tight and here it's moving, and right here is where all the flexation is occurring in the cone. And that's where the breakdowns are going to occur. So I'm just going to do that with a little bit of probably I don't know, nail polish I might use on this, because it's really very minor stuff. So let me get going on that. Here's my my choice here. Charm Limit. Wow, that's kind of a weird name, isn't it? Nail polish. And what is nail polish exactly? This nail polish is hard to read there. Butyl acetate, ethyl acetate, nitrocellulose isopropyl alcohol, sterolaconium hectorite. Oh, I never heard of that. Keep away from children. Yeah. And really kind of curious about what's that bottom right symbol supposed to be showing there. Okay. Let us apply it to the speaker. So for really small stuff like this, I just put a little of this on it. You can actually see some like could call them longitudinal cracks beginning to form in here too. So hopefully this will stop the cracking, but in fact it's going to redistribute the forces, and the cracking forces will just show up somewhere else here. Somewhere else on the speaker will start to crack. Is it cracking because of use? That's an interesting question. So could you just kind of leave this thing sitting around for 50 years and come back, it's exactly the same? Is it the actual using of the speaker that encourages this cracking. You'd have to think so. Would it crack just sitting here? Wood will. Wood will crack just sitting there because it dries out. I don't think they make many speakers out of wood. Maybe that's why. If I start laughing uncontrollably, you'll know it's the fumes here. Okay, for this next one, I've got a little bandage I'm gonna try to stick on it. So we really don't want any air leaking through these holes. So it's not just a question of stopping the continuing tear, but you need to seal it, stop air from coming through. In the worst case, you would end up with a buzzing sound, just like putting your lips together and blowing air through it, which I won't demonstrate right now. Now often I'm doing this with just white glue, carpenter's glue, nail polish, and I wouldn't normally do a patch with nail polish like this. Okay. So that means when I put the gasket around here, the gasket is on the front of the speaker. It's not on the back. It's on the front, and it's trying to contain the air, not let the air get out here. Put the board on top, no air gets out this way. All the air has to come out this way onto the front, onto the front of the board. Nothing on the back. Will that work if I just put this cord in here? And that's the question. Will I get that effect? And yeah, I think it's going to work. I'll go around a couple of times. I think what I'll do is I may stick it to the board. Yeah. Stick it to the board with some double-sided tape or something, so it's on the board. And then when I put the speaker onto the board, bingo, we're done. These will probably all need another coating of stuff. You can actually see there's a divot in the speaker right here, and that's probably why it cracked there. Some kind of misshapen thing. I don't know. Why would it have a bad shape to it right in here? Who knows? Don't know what I'm proving by this, but a distance here. And the distance here. And here. That's about the same. Maybe a little more here. Maybe that's why it wore out here. Okay, good for now. Get the board and get that ready. Okay, so here's the speaker baffle board. And I mentioned before about the spears that are often on these screws. I think the idea is they're putting a nice point on so you can locate the holes easy. But in fact, you can punch a hole in the speaker really easy. That's what's really easy. So the seal has to be made inside these screws. It's got to be made there. So we would have to run this like this around. Then the speaker comes on. The speaker can go on 4 ways. 1, 2, 3, and 4. Which way is the right way? I have to figure that out. This has a top and a bottom. The way it was in the radio, this was the bottom. I recognize the center screw here. So this board is lifted up here for some reason. Probably the screw here is lifted up, maybe? No? No? There's nails here. It's just come up for no reason. Okay, now I've gone and dropped the screws out here. Okay, so we'll dry fit the speaker here. What's going on? Which way now? Which way? Let's get it. Okay, now we can tell which way the speaker was by the way the dust collected in it. The speaker was sitting this way. The dust collecting on all these upper surfaces here. Sitting like that. This is the bottom, so it must have been sitting like this. What I'll do is I'll run a circle of this gasket material, and we'll put the speaker on and see what it feels like. I got tons of this material, so I don't have to worry about it at all. So that's kind of how it would be. You can see how you'd have to hold it in place somehow. Double-sided tape would be the way. Can you just sit there? Just sit there? Probably can't get it to just sit on here. There. Okay. That's good for a test run. So what I want to find out is, does this metal edge now contact this board, or is the gasket holding everything up a little bit, which is what I hope it's doing. So we're going to take a close look at this edge here. As soon as I can find where the camera is. Here it is. Certainly working here. Looks pretty good. Oh, it's solid here. So perhaps the gasket slipped because I was having a hard time getting it to stay in place under here. Let's go over here. It's pretty solid back here too. Then we get a lift on one part. So there's some gaskety action there. Maybe a little bit there. Let me just let go of the camera. No, that's rock solid. So I'll bet you the gasket slipped out here. Let's see. I'll just lift this up very carefully. Where's the gasket? There is no gasket right there. Right. Okay, so that test proves to me that the gasket idea will work quite nicely. So in the end, when I tighten the speaker down, the frame will compress this gasket slightly onto the rim of paper on the cone, and presto, front seal done. Fantastic. And so what I'll do is I'll either put some spots of double-sided tape here and there, hold this down maybe with two turns of this stuff, and speaker down, problem solved. Sounds like a great idea. That's what it sounds like. Okay, so that's the double-sided tape on there with the backings still on it. I don't know about you, but I find double-sided tape extremely annoying stuff. All it's got to do is just hold the gasket in place while I put the speaker on it. That's all it's got to do. One little job here. So okay, so I'm going to peel off the backing and then stick on the gasket. Skip just starting to come in on CB. But not enough to listen to yet. Ah. There we go. Okay, now we'll just run the gasket here. was so much fun. Let's go around again. Go. There we have it. Gasket ready. Now, when I drop the speaker on this, I don't want to be doing this again and again. Now, the speaker wire, a cable that comes from the radio, is really very, very long. It's really long. In fact, it's been extended by somebody with a rather large extension for some unknown reason. I don't think I have to worry too much about which way I put it. In the end, if I make a mistake, turn about which way I'm rotating the speaker. And also, ultimately, if I have to take it off, I don't think it's the end of the world. This is the way I figured it went. One down. Okay, I'm centering it up on each one of the posts. I think that's wonderful. Now the nuts that go on here, surely to goodness there were washers in there, weren't there? Well, I'm going to put washers. I can't. How could this have possibly worked? So somebody put this together without the washers. That's not going to do well. Pile of washers here. Kazoo night. And more like that. There we are. Now I can get at the back side of these screws, of course, because they're kind of loose. So tightening them up, I can just get under here and hold it to tighten it up. Don't know how tight you really want to make this anyway. Once the cover is put on, though, you can't access these screws anymore. So with this mounted in the radio, if one of these posts is really, really loose, you know what, you can get around it. There's other ways. That's nice. Just finger tightening them right now. It's probably not enough to compress that gasket I put in. Just doing it by hand, but for now. There it is. Okay. Let's see what we got here. Now, if you're staring at this transformer, maybe you've noticed there's a wire just sticking out here, just going nowhere. There's tape here. So, not original. This is not original. So I think a lot happened to this radio at some point in its life. There we are. Everything looks fine. Looks like a little blob of hot glue dripped onto there and got stuck. I'm just going to leave it. Okay, we'll tighten these down all the way now. I'm reading a 400-page paper on the effects of glaciation on landforms, post-glaciation. 400-page paper on it. Isn't that exciting stuff? She's solid. I think it's a thumbs up on that. I think that, so now from here, it really is getting everything into the cabinet, I think. And we'll get everything in there kind of set up to make sure it's all okay before I bolt it all in a final way. And I have to do the grill cloth. But that's good enough for now. It's great. Another beautiful day today outside. And we're going on a car trip down to Toronto today. So that's it for now. Fantastic. I'm pretty happy with how that came out. I was quite worried about this when I first saw it. Turns out, not a big deal, I don't think. Thanks for watching.